folks, welcome back to another video. Today we're looking at question 1717, maximum score from removing substrings. The way we'll be solving this problem is we're basically handling the substring and looking at it at either A and B or B or A based on which score is higher. Looking at reducing it based on that string and then like moving on to the next string. This problem is not necessarily a tough problem. It's just very verbose, especially because it's Java. So let's just get started. Let's write the skeleton of the problem first, and then we can like write the main methods. The first thing you need is actually take the total number of points. That just set that to 0. If we have x greater than y, then you need to reduce the string. So let's say that we have a reduce string method that basically takes in a string s and like the pattern that we care about, either a, b, or b, a, right? And we'll come to that later. So if it is x is greater than y, you can call it reduce string on S with AB because X corresponds with AB, right? Once you have that, you need to know how many total points you got from that. So to be able to calculate the total points, you need to know how much the length reduced and multiply it by X. So let's say that this just gives you back the string after first edit, right? Based on this, you can say total number of points, right? So you need to add that. So total number of points would be, let's write another method for that, get points. So you need the first string, so basically that is string s, and then you need the second string to calculate the difference between them, right? And then you need the number of points that you got for each reduction, so you need to pass an x. So this will also be another method, and since this is calculating points, we can just assume that the type of value that is returning is int. So this would be private int get points, and this will be string a, string b, and int points. Yeah, so we'll come back to that later. And in this case, we said that this would give back a string because it will give us what the string looks like after it's been edited. So the return type there would be string. And you actually need that for the second reduction. So what string do we start off with and what we subtract? So this will be called after second edit. But here, the string that we're reducing is actually not S, it'll be after first edit. And the pattern that we're using is not AB, but BA. And we also need to calculate total points and add that. So here, the string that you're comparing it with is after first edit, and you compare that with after second edit. I think I made, yeah, second edit, and then you multiply it by Y. Right, and let's handle the other case as well. So basically this will be sort of mirrored, right? But let's go through this. So you'll start off with BA, and then the points that you'll be calculating is Y, right? And then the second string will be AB, and then you'll be multiplying it by X. And in the end, you'll be returning total points. Right, seems like we're done, but not yet. We need to write these two methods. So let's actually tackle the easier one first. So this would basically be subtract a dot length, right, minus b dot length. So this will give us how much it got reduced by. But the thing is, this has to be divided by 2 because you're subtracting two characters, A and B, or B and A, so you divide that by 2. And this is multiplied by the number of points. Okay, so I think this method should be good. While I'm returning int and doing some sort of like multiplication or addition, you always want to check whether it it is within the bounds of int or you need to take long, but I think here int should be okay. So that method looks good. Let's look at the reduce string method. So let's extract the character. So let's call the character C1 would be equal to pattern dot character um, character at 0. If you just extract it right now, you don't really have to keep like writing this again and again and again. So that's the reason why we're doing that. So we have character 1 and then we have character 2. So since after we remove a character, remove a pair, there's a possibility that that pair can be formed again after you remove a given pair. So that's when you have examples like that, it's very useful to use a stack. So let's just go ahead and initialize that. New stack. And in the end, you need to return the string. So we'll have a string builder that will convert to string later. New string builder. Okay, awesome. All right, so basically we need to iterate through all of the characters in string S. So let's say character C in s.to char array. So once you have a character, if character C is equal to the second character, and if the stack is not empty, and if the last character that we added is equal to the first character, that means there is a match. So what we would do is we would just pop the last character. If not, if this condition is not really met, basically we just add that character to the stack. So it's pretty simple here. And this will basically take care of cleaning up the entire string. And when I say clean, it basically removes any pairs that it sees. And once that is done, you basically need to iterate through all of the characters in the stack and add that to the string. So while stack is not empty, you need to keep adding those characters to the string. Insert, and the reason why we use insert is because we need to add the characters at the very beginning. So when you're adding characters to the stack, it'll be placed in the reverse order that we want. So that's the reason why when we keep popping it, we will add that to the very beginning so that it gives us a string in the right order. So this will be stack dot pop, and in the end, what we need to do is we need to convert that string builder to string, and I think that should be it actually. All right, let's try compiling this. Really hope stack dot push c equals okay. So let's check that. If character c is equal to c2. Oh wait, this should be a stack that stores type characters. Let's try that again. Okay, so the first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the entire solution. Time complexity of the entire solution is of n, since we are iterating through the entire string twice, and the space complexity is also is O of n, since we are using a stack to keep a track of all of the characters. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate that. It keeps me motivated to make more videos. Thanks so much, and I'll see you folks soon.